Hi. So in this project, we are going to try to build a model that is going to find similarity between text, right? And then we are going to mount that model that we have built onto a web application that later on we are going to deploy. So this is a machine learning plus a web development of project where the main motive is to find similarity between text and to build an application that is actually a web application where we can use this model of finding similarity. So let's first understand what we are going to do. So what we are doing, or on what it is that we are actually working on. Text similarity aims to identify how similar documents are on a word level. Essentially, we may define text similarity as attempting to determine how close two documents are in a lexical similarity and semantic similarity manner. Now, these terms might not be something that you were able to understand from this, but a language has a lexical part and a semantic part. Now, lexical part is something like words, alphabets that create words, then words that create sentences, sentences that create documents, right? And semantic is actually the part of the language where we are trying to convey meaning, right? The main motive of communication is to convey what we want to say, right? Or what we want to express. So that is handle, or I would say, comes under the semantic part. Next, the traditional approach to compute text similarity between documents is to do so by transforming the input document into real valued vectors. The goal is to find a vector space where similar documents are close according to a chosen similarity measure. Again, this is something that is not really good at explaining itself, but what we are trying to do is trying to convert our text into numerical values which later on can be used to find similarity between two texts, right? So what we are trying to do is, let's say that there's text A and text B. So text A is defined by number 5 while text B is defined by number 2. So we can say that both of them are natural numbers, right? Again, that means that they are closely related. But if text A was, let's say, determined to be 5, but text B is determined to be -7. Now, these are not natural numbers but integers. So we can say that, yeah, they may be closely related or maybe not, right? So this is how we are going to see, or we are going to compute if two texts are similar or not. Though this was a very dumbed down and not really accurate version of what we are going to do, but when we are coding or building the model, it would be much more, yeah, I would actually much more explain this when we are coding itself. So details of the project. First, we will be building different kinds of functions that will help us in pre-processing the data and convert the data into vectorized formats or format. Next, we will build a web application on Django to mount the similarity model. Lastly, we deploy the Django project on Heroku through GitHub. So building the similarity model. We start off with building functions that helps us in extracting and pre-processing the data. Now the clean data is a must for finding similarities, right? Which is also further processed by removing stop words. Now stop words are actually words that are repetitive inside your text but don't convey much inside the text. Meaning that there can be words like a, the, is, right? In the text, there are so many repetitions of these kinds of words, but in general, they don't convey much of the information. So these are also called stop words, which we will be removing. Next, we convert this clean data into vectors, that is an array of numbers representing the data as numbers. Lastly, we build a function which finds the closeness of these vectors called cosine similarity function. And actually the algorithm that finds the closeness is called cosine similarity. Second, or the I would say the second part of the project was Django web application building. So this is the second part of the project where we will build the web application using the framework Django. We mount the model we built in the previous part on the Django project here. Now this is the last part of the project where we will be deploying the Django application on Heroku using the connections to GitHub. So now we can just move on to the first part, that was building the similarity model. So this is the first part of our project where we are going to build the similarity model, right? So as you can see, the first code block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook itself. And as you can also see, we are mounting the content and then the drive folder or drive directory inside the content directory from our Google Drive directories, right? As you can see, I'm importing some libraries, and though these are most of the libraries that we are going to use, I think some of the libraries are not listed here, but I can see that they might be down the lane, right? Like pandas and so. Yeah. So first of all, the NLTK library. Now, what is this library? This library is actually an amalgamation for the NLP, that is natural language processing library, in the sense that it stores data, or I would say text data, on which you can work upon. Just like the sklearn library, it stores a lot of other library and functions too, right? As you can see from the next line, the NLTK stores a library that is corpus, from which I am importing my stop words, which was as defined in the last introduction video, right? So NLTK has a lot of other libraries and function defined in itself, which I think we are going to use and you will be able to see down the line, right? So NLTK has functions which are used to tokenize the text. Tokenize means we extract words from sentences, right? It has libraries to lemmatize. Now again, these terms might not be something that you have heard before, so you can just go and Google search them once, because I would be just giving a brief about them and it might not be much of an explanation, right? So you can just go on to Google and type these out. The reason why I'm actually, you know, stating out these terms is because though we aren't using all of the terms or functions exactly in the code itself, but it is good to understand them, as to you can also modify my existing code to build a better version of the similarity model, right? So for that, you might want to, learn more about these functions that NLTK has. Right. So NLP is actually a domain where we understand and know more about how to train models, right? Models in the sense machines to understand our language and to use our language, right? We can work on text generation, right? Models using, or I would say models using data from the corpus and then training themselves to generate text to, there's machine translation also, which means that I'm trying to convert a sentence from maybe English to Japanese or English to French. So for that, NLP is the like HUD for these kinds of processes. Next is the Ray library. Now Ray library is for regex. If somebody has, if someone has actually already used this, they would know that regex is generally for data, I would say not say data, but text handling. Like if I want to extract some particular things from my text, I would use regex. Or if I want to handle or manipulate text, then I would be using the Ray library. Because inside Ray library, we have functions like find functions, where you can find a specific character where you can find specific combination of string inside your text data, right? Though it has a lot of more functions that you will be seeing later on. Next is the TQDM. Yeah, this is basically a library which helps in understanding how long a process might take to cover up and what is the state of the process, right? Next is the time, request, and random. Now again, request is not exactly, yeah, I won't be using the request, but request is basically a library which holds functions which helps in finding out request and responses, right? There's get request, there's post request. So if you are making those requests and you want to find out the response for those requests, this library is pretty handy. So these are the texts that I'm going to take as an example to see how close they are to each other. Both of these texts talk about characters in movies, right? So later on we will see how close they are to each other. First you can see is the cleaning function that I have defined, right? So what the flow of the, I would say the flow of this part of the project is that first we build a function that pre-processes the data, cleans the data. Next function we build is to remove the stop words. Next function we build is to convert the pre-processed and clean data into our vectors. And the last process would be, or last function would be, to now actually, find the similarity between these two vectors that we have defined and see how much similar they are to each other, right? So for that, moving on, the first function is the cleaning function, that is pre-processing the data. And inside cleaning function, I have defined some smaller functions which I am going to use. So in a sequential manner, the first function is the clean HTML. Again, from the name itself, what I'm trying to do is remove the HTML tags, right? I've already taken string which is pretty much clean, just has punctuation and stop words and these, right? These usernames. But it might also happen that there are sometimes text which has HTML tags in it, right? When you're trying to web crawl and get extract the data, sometimes HTML data also comes with the intended data. So to remove that, I am building the clean HTML. And here you can see there's the use of layer library having the compile function, which is telling that if there is any, I would say, sequence which has values inside the open and ending brackets, then you have to remove that data, right? And using the substitute function of the array library, what I'm doing is if there's any sequence that is true for this kind of data, then remove that and replace it by an empty string, right? This is what is happening here. And then return the string, updated string. Next is replace URLs. Again, similarly, I'm using the compile function, which stores in the sequence which we are looking for. And again, here, if we find that sequence, then we are going to remove that sequence or replace that sequence exactly with a empty string, then return the updated string. Similarly, to remove emails, now we will be removing anything that holds an @ sign, right? And has a dot. Next is the miscellaneous, that is again removing a new line character or a tab character or a single quotes, right? All of those data will be removed from the string also. Then I'm just calling them out and finally returning my updated string. Now this is downloading the stop words. So when you install your NLTK package for the first time, right, what happens is that all of the data or the corpus data is also installed. But sometimes it happens that the corpus data is not, automatically installed. So for that, what you can do is just type in NLTK dot download and the corpus name of the corpus that you want to download. So it would download that for you. If it is already downloaded, it would show something like this: package stopword is already up to date. Next again is the stop words. So what I'm doing is, now as you know, we don't have just one language in the world. There are a lot of languages, and for each language some words are defined to be stop words in them. So what we are doing is we are calling out these stop words for the English language here, right? Next, as you can see, is the function that is defined as, yeah, from the name itself, remove stop words. It is pretty much clear what this function is doing. Let me just explain it, how it is doing, right? So the first thing that is entering inside this function is a sentence. Next thing that happens is that we are building a list using the split function of these strings to build a list of words from that sentence. Meaning, if I have a sentence, I am happy, the words variable is going to hold a list that has I am happy. So three words, right? Next, what I'm doing is using list comprehension, I'm finding out if my words list actually has stop words in it or not. For example, taking the previous example itself, I had a list that is I am happy, right? So let's say that I is actually a stop word. So what happens is that it goes through each and every word inside the list, and here it is able to see that I is actually a stop word. So it is going to remove that. Then next word is am. It is not in the inside the stop word. So it is going to keep that word. Then next is happy. Again, not in the stop word. So it is again going to keep that. So this filtered sentence is going to have a list, not exactly, is actually the list itself storing the value am and happy, right? So two words now, rather than three. The last thing that I am doing is again building a string from the filtered sentence because it has only two words, right? Now what I'm doing is joining those two words together to build the string itself and then return the string here, right? So this is what exactly remove stop words function is doing. So with this, I'm going to stop here because the next section will start off with what word vectorization is, how word vectors look like, and why we are actually, though this was also covered in brief in the introduction part, but again I will tell you why we are converting into, converting the strings into numbers and how they are going to help us in finding similarity between the. So this is the second part where, as you can even see here, using the cleaning and the remove stop words function, you can see our initial, our initial text was j.walk at the rate the username something 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 something, right? And here you can see jwalk, all of that something something is removed, and then I read the article, he essentially said that instead of, and just the usual English language, right? So even here you can see that the even here you can see that the, right, next you can see that the first line is when we just use the cleaning function, then we use the remove stopword function, and that whole long ass sentence is now converted to a smaller sentence, like a really small sentence, right, as compared to the above one. Similarly, for our text 2, you can see the first is somewhat longer as compared to the second, which doesn't have any of these stop words, right? So this is how we have cleaned the data. And next is, right, so the next thing I'm doing is actually loading the embeddings, or what I should call word vectors, right? So as we know, natural language processing is the process of, is the process of processing different languages and extracting useful information from a given sequence of words. That is something that we call as text. So words embeddings or I would say word embeddings or word vectorization, is a methodology in NLP, that is natural language processing itself, to map words or phrases from vocabulary to a corresponding vector of real numbers, which is used to find word predictions or word similarities, right? So word embeddings, now I will be interchangeably using the word embeddings and word vectors terms, right? So they help in the following use cases. For one, we can say that it is helpful while computing similar words or understanding if two words are similar or not. Next is text classification. They help in text classification also. Next is document clustering, finding similar documents or grouping documents, right? There are also many more functionalities of what they do, but basically here they will be helpful in finding similar words and grouping similar text. The next thing before moving forward is understanding a little about what cosine similarity is and why is that, that we are using cosine similarity as a metric to understand if two texts are similar or not, right? So we can understand that word vectors are actually dimensions depicting a point in space. Now, this is not going to be really easy to understand. So try to follow through with me, right? Let's say that there is a 2D space, right? This is the x-axis, this is y-axis, and 90-degree angle with the 0, right? Let's say I have a word vector v1 that is 1 comma 0. For those who think this is bad, I know this is really bad, but till the time this is understandable, please don't commit. So as you can see, v1 is a vector having 1 comma 0, something like here, right? 1, 1, 2, again similarly 1 and 2. Now there's another vector v2 which has a value of 0 comma 1, right? So this is somewhere here, this is somewhere here. So I have a v1 vector and a v2 vector. So v1 is here, v2 is here. So what is cosine similarity? So cosine similarity is basically finding the cosine value between these two vectors, right? So as you can see, this is a 90-degree angle, right? So cosine of 90 is 0. This tells me that vector 1 and vector v2 are not similar, like not at all. They are least similar to each other. But let's say, for example, that I have again two vectors like this, and this is somewhat, yeah, okay, not this exactly, remove this, somewhat like this, right? You can see that the magnitude is pretty much different for V1 and V2, and still the angle here is closer to 0, right? Closer to 0. This means that V1 and V2 vectors are actually pretty close to each other, meaning that V1 and V2, which are actually defining text 1 and text 2, are very close to each other. This means that text 1 and text 2 are very close or similar to each other, right? So this is why cosine similarity is a very good metric, because text 1 can have 200 words, right? And text 2 can have only 25 words, which again can be seen that the magnitude is pretty long and big, the magnitude is small. But what both of these tell us is that text 1, text 2 are similar through creating vectors and finding the cosine value between these vectors. So this is why similarity or cosine similarity is pretty important, and again a very good metric in finding out if two texts are similar or not, right? Again, moving back to our code, so the first thing that I'm doing is actually loading my word embeddings or word vectors. And as you can see, it is stored inside the word embed variable. And word embed variable is not a dictionary, but actually, I would say actually an object of the, yeah, it is actually an object of the Glove library, right? Now you can again, if you want to search what Glove library is, what word vectorization is, how we can use certain libraries for word vectorization. But simply to understand, you can type in any word inside the quotes and it will give you an array object. That is the actual word vector for that word itself, right? So for the word the array or the word vector is this. So this is of 50 dimension, right? So you can in a way say that while we were actually dealing with two dimensions in our example, this is the 50 dimension. You can't imagine that, but for understanding, you can say that yeah, there's 50 dimension space here, and this array is actually telling you a point in that 50 dimension that where this point exists, right? So that we can make a vector from our 0 point to that point in the space to build the vector. This is what this means. Again, this might not have cleared out or might have made even more doubts in your mind, right? So you can again search what word embeddings are, right? Not exactly word embeddings, but search how exactly word embeddings work, right? Because these are not easy to grasp. And if you have a mathematical background, you might have easily understood this. But if you don't have a mathematical background, this is going to be a bit confusing. So, in brief, or trying to simplify this, we are building two vectors which depict, I would say, yeah, we are building two vectors which depict two text, and we are finding the angle between these two vectors. If the angle is close, or is the if the angle is very small, this means that the text is similar. If the angle is big, it means that the text is not similar. But as you can see, the embeddings, sorry, the embeddings or the vector is for the word, not the text. So how are we building the embeddings for the whole text? Now you can see what I've done is I've created a empty, not exactly empty. I've built a array object that's of the dimension 50 and stores 0. And what I'm doing is first I'm yeah. So in brief, what I'm doing is that I'm adding the word embedding values to my empty embeddings. So what happens is that each and every word has a different embedding values, right? Or different array values, right? So what I'm doing is I have a array which stores 0. Then the first word has some embeddings which is added to my 0 array. Then the second word again has some embeddings which is added to my 0 array. But now this is not the 0 array because it has already the values added, not exactly, yeah, this is pretty confusing. But what I'm trying to say is that let's say that there is a variable c which has a value 0. Then there's a variable a which has different values, right? In a for loop, the first value for a is, let's say, 2. Then in the second time loop, it has a value of 7. So what is happening? I'm adding c with a. So first 0 plus 2 is happening, then 2 plus 7 is happening. So this is how what I'm doing is adding on each and every array object for each and every word inside my text to be added into one array object, that is document embeddings. So as you can see, well, not exactly see, but later on, yeah, here you can see the document embeddings, right? Because yeah, So the first word is Joe, right? So what happens is first I'm taking out the word embeddings of Joe into the array. Then I am adding this value into the zero array, right? Now something added to zero becomes that thing itself. So I have the value of the first words array embeddings. Next, I am finding the second word's embeddings and storing it in array. Then what is happening? The value of the first word is here, the value of the second word is here, and the second word values are now being added to the first one, right? So this is having first plus second. Now in the next loop, I have the third word embeddings inside this array. So this is 1 plus 2. This is the third one. Now the third one is adding into the 1 plus 2. So it has 1 plus 2 plus 3. 3 embeddings in total, right? So this is how I am actually getting my word embeddings for the sentence out of the words, or I would say using the words. So this is the same thing that I'm doing for the second one also, and I'm using try and excel block to see that there might happen that there is some word which is not inside my word embeddings file, so there would be no embeddings for that, right? So if there is no embeddings for that, I am finding the count of those words. Fortunately, there was no word inside my text that was not inside my embeddings file embeddings file, right, word vector file. And similarly for the second text also, there was no word inside that text which was not inside my word vector file. So once I've created my document embeddings or the text embeddings, as you can even see here, what I'm doing is, what I'm doing is building my cosine similarity function. So as you know, or maybe you don't, the way to find angles between two vectors is to find the dot product of that, right? Then to find the dot product, what we are doing is first finding the dot product, then dividing it with the magnitude of each of the vectors, right? This is how we find this. This is how we find the angle between two vectors. So this is exactly what we are doing. We have A and B, two vectors, taking the dot product, then finding the magnitude of each A and B, then dividing that with my dot product and returning the cost value. So here you can see that there's document embeddings 2, text 1, text 2, finding the similarity is 0.81, which is good because as we know, both of these sentences were actually talking about movies and actors, right? So we can say that yeah, these sentences are pretty similar to each other. And another thing that I want to show you is that look at here. What I'm doing is using the function concatenate inside my, this is inside the NumPy library, which is used to concatenate two arrays, and these two arrays are concatenated column wise, meaning we had first our document embeddings of dimension 50, but now we have word embeddings of dimension 100, right? We have word embeddings of dimension 100. So this is what happens. So in concatenate, the first array having 50 dimension is joined with the second array having 50 dimensions. So now the dimension has come to 100. And similarly, I have done this for the second one also. So now I have a text representation in numbers having 100 dimensions, right? But again, if I use the cosine similarity for them, I get the same exact result, right? So this is one reason why both of them are important. Sorry, why both of them I'm saying why cosine similarity is a very good metric, because what I've done is increase the dimension, meaning that somehow I have also increased, or I would say displaced the point in my space, because first there was a 50 dimension space, Now it is a 100 dimension space, and the point which was on the 50 dimension space now has displaced in the 100 dimension space, but also the magnitude might have also changed, but still finding the similarity for both of these points, we still get the same value, right? So with this, we have completed the first part, that was building our similarity model, and we will move to the second part, that was building the Django application, right? The web application. The second part of the project where we are going to build a web application using the framework Django. But before moving on to the code, let's first understand what Django really is. Now, Django is a Python-based, free and open source web framework that follows the model template views architectural system. It is a web framework that has a set of components that helps you to develop websites faster and easier. Now, you might not have understood what model views template architectural system means, but basically, a web application in terms of Django has three parts. First part, that is the front end, which includes your CSS files, JavaScript, HTML files, right? So HTML is here termed as the template. Next is your backend part, which is termed as views. So in your backend part, you manipulate data, handle data, and retrieve, store data, stuff like that happens. And then you also render your HTML pages, right? So this is handled by views inside the backend. And the last part is the models part, that is related to your databases, storing of values, building of tables, right? All of that is in the umbrella of models. So this is the model views template architectural system inside Django, but we will be using only templates and views only for the moment. Now we can move forward to the code part. So first we are going to set up the code, and for that what you have to do is first create a project directory, right? Create a project directory. So I have created a project directory that is similar text, right? Named similar text. And the next thing that you have to do is build an environment for this project. So if you're using an IDE like PyCharm, right? Like I'm using PyCharm also, you can just click on files, click on settings, and then a pop-up will open. Then click on projects, right? Then click on project interpreter. And here you can see that there's a project interpreter here. So if there's, if this box is empty, just create a new, interpreter or environment using the settings button, then click on add, and then just type in the name of the environment you want and where you have to store that environment, and then choose the Python file or the Python application if you want to use the 3.7 version, 3.6 version, right, 3.8 version, or whatever version. Then click on OK. So I have already created an directory, right? Sorry, not directory, environment, and that is also named as similar text. Then once you have created the environment, we can move to the next process, that is to go into your command line and go inside the my site directory, right? Here you can see that inside my similar text, which was the project directory, I have the my site directory here. So similarly, go inside your command line into the my site directory, then run the command pip install r requirements.txt. So once you run this command, what is going to happen is that all of the packages and dependencies required by this project is going to be installed inside your environment, so that later on your project can use those directories as needed, right? So once this also happens, what you have to do is run this command, python manage.py migrate. Now this command is specific to Django, right? This is not a Python specific command. And once you run this command, all of the tables that are required by this application is going to be sorry, is going to be instantiated with this project, and then your application can start using the tables inside your databases, right? So this is important for that. And also understand this, that Django provides you with the base project itself. You don't have to code anything from scratch. It already provides you with the base project onto which you can build, like you can build your code so that you can portray new functionalities onto the website you are building, right? So even for the base project, you have to run this command so that the tables that are required by the base project to run are also instantiated, right? So this is the last command, but we won't be running this command right now. And as the name suggests, right, run server, it is going to run a local server onto your machine to, yeah, you can see the website then if it is running in the properly fashion or not, right? So later on I'm going to show you what this command do exactly. But first of all, let's move forward to see that there are two directories here, my site directory and post directory. So my site directory now is the project directory which stores the settings, vsgi py files, right? So inside your settings you can see a lot of variables are defined here, right? And you can see the installed apps. Now these apps, yeah, first of all, let me define what project is and what an app is. So project is like let's say overall website inside which there are sub parts of that website built through apps, right? So there's a big umbrella of that is the project, then there are small parts that are under the umbrella which are apps. Now apps provide functionalities to your website, and as you can see here, some apps are defined like the authentication app, sessions app, messages app. So these are pre-built apps by the Django project, right? These are the apps that are provided by the base project. And these apps handle the sessions of your website, the authentication in your website, and stuff like that. So this was an app that was created by me, which provides a functionality or is created to provide a functionality onto my website as I want, right? So these are the apps, and you can see some of are already pre-built. Here you can see the middlewares, security middleware handling the security for the website, sessions middleware, CSRF middlewares handling the CSRF tokens in the forms of your website if there's some forms in your website. Next, you can see that there's databases too, a variable for databases, which is not exactly a variable. Yeah, it is a variable storing a dictionary. And you can, from here, you can actually connect your database application to your web application so that you can have the functionality of retrieving and storing your data, right? So you can use applications like Postgres, you can use applications like MySQL and some other database applications also. The last part would be, yeah, the static files. So Django actually takes a little more care of static files in the sense that it stores your static files in one directory itself so that your server understands that, yeah, this is the directory where all the static files is present and I have to access those static files from this directory only. So for that you have to set up your static URL and static root. Static URL tells you the path where the static files are present, and static root defines the directory itself where the static files will be stored. Now for static files, they are the CSS, JavaScript and images that you might be using on your front end. So this is the settings file where maybe changing or adding on stuff will change the way your code or the project itself is working, right? So this is a very important file, and if there's something that you didn't understand, you can directly go on to the Django docs. They are pretty easy and straightforward. So if I was not able to properly, explain things, you can go to the docs ones and see if they are good enough, right? If they are clearing your doubts or not. So the next thing is the apps, right? So the polls app that I created for the extra functionality that I needed onto my website. The first thing that we are going to do is go inside the templates. And here, as you can see, the template is storing the HTML file. and you can see the CSS part, and right, the CSS part, there's a big ass CSS part. Then scrolling down, you can see that there's also a form that I've created, right? A form that I have created, which is going to take values from the user, and then I have a submit button, which is then going to transfer those values from the front end to the back end. So what happens? This form is showcased to the user. The user inputs the data, and once the user inputs the data, it he or she clicks. Sorry, he or she clicks on the submit button, and then the data is then given to the backend. That is our views, right? The views is inside the polls only, right? The polls is the application, so we have the views or the backend inside the polls. Then in the views, here you can see that I'm storing my data inside two variables, right? Text1, text2. So what we do is inside our views, we create functions that are going to help us in rendering our HTML pages, in data manipulation, data handling, and finally printing out the result. So how all of that is happening? First, see that I have defined a function that is index func, right? So this function, first of all, is taking the values that was inputted by the user onto the front end, in the front end, right? So I have text1, text2 with me. Then I'm using the cleaning and remove stopword functions, right? Both of these functions to pre-process the data. Then I'm doing the same thing that I did before, building my document vector, right, from word vectors. So I have document vectors for both of the text. And lastly, using my cosine similarity function to find the similarity. So as you can see in this function here, it is first taking the data from the front end. It is manipulating the data as we want. Then it is finding out the result, right? It is finding out the result. And finally, I'm sending the result back to the front end using the context parameter. Right, this is called the context, right? This is a dictionary having my similarity or the result of my manipulation here, and then it is sent through the render function. So you can see this function has a return, and the return is also having a render value, sorry, render function in it, which is again sending a request first, then the request is sent and it understands that it has to render the index HTML page, and then it sends the result too. So what is exactly happening here is that I have created an account, sorry, I have created a function. It is rendering an HTML page. That page is showcased to the user. The user inputs the data. Data comes to the backend. From backend, the pre-processing and document vector creation is happening. Finally, we get our results using the cosine similarity function, and then it is stored inside this variable. Finally, this variable is sent back to the front end, or the value of the result is sent back to the front end, right? Now you can see that I have already called the cosine similarity functions, the remove stopword function, cleaning functions. So what I did was just create a utils.py, which is holding all of these functions which we needed, right? And then what I'm doing is just importing them here and using them directly. So as you can see, this is how the views work, or the backend inside, or the backend implementation is done in the Django project. One thing that you might have noticed is that though we have created the function, we have never called the function. So how is the page exactly rendering, right? So for this, let's move to the URLs. So urls.py is the page, or is the code where we have mapped when this function is to be called, right? You can see there's a path function here, and it has a parameter index func. So what we have done is that we have created, or we have mapped this function with a URL, right? So once a user goes onto the URL, my project understands that yeah, the user is trying to access this URL or this page, so I have to call the index function. Once the function is called, the function understands through its render function that yeah, I have to render the index.html page. And that is how once the user goes to the path or the URL, that index.html page is loaded, right? So this is how the function is actually called. And from then on, you understand, right? How the front end is loaded, data goes into the front end to the back end, result comes back from the back end to the front end. So with this, we have at least understood how the code is running, how the Django project is working, right? So the last thing I would do is run the final command, that is python manage.py run server, right? So this is going to start a local server onto your machine, and it would output a local host URL also, onto which once you access, this index.func function is going to run. And here you can see the page is again loaded here, and you can just type in the values here and just click on submit. And here you can see the similarity value has changed. Yeah, the value has somehow changed, but the value is right here, right? So we got our value here, which was our result. So with this, we have completed the second part of the project, that was building the web application onto the Django framework or using the Django framework. So with this, we have completed this part, and we'll move to the second part, that is deploying this project or this web application onto Heroku. Third part of the project, where we will be deploying our web application on Heroku. But before we start off with Heroku, we have some files which are like commands for Heroku to understand, right? So let's start off with runtime.txt, nltk.txt, and procfile. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. And here you can see I have specified I'm using Python and 3.7.10 version of the Python, the Python language. Next is the procfile. So procfile is the mechanism for declaring what commands are to be run by your application in Heroku platform, and the help and with the help of which file, right? You can see that the mysite.wsgi file is what the server will take into reference while trying to run those commands. The commands that I'm actually talking about is what I specified in the last part, like the run server command and the migrate command. These commands are actually executed in the Heroku server using the proc file, so that the code is set up in the server also, right? So the last thing is the nltk.text, and it is only storing one word, that is stop words, right? So what is actually the need for this text file, right? So we know we are using the NLTK library, right? And the NLTK library has stop words in it, which is again what we require so that we can use those words in our remove stop words function, right? So the way Heroku server works, when installing the NLTK library as a prerequisite for the code setup, it doesn't automatically download the corpus also, right? So we have to create a text file that indicates all the corpus that we want to download, or the corpus that we want to download, right? So for that, we have to tell Heroku that stop words to be also installed, right, with the NLTK library, so that later on it doesn't create some problems when stop word is being called inside the code. So this is why NLTK library is, sorry, NLTK.text is also created, and stop words is written inside that. So with this, we have finally understood, right, all the prerequisites for deploying the code onto Heroku. And the next thing that you have to do is actually upload this code, right? Upload this code onto one of your repositories in GitHub. So as you can see, I have a repository, Similarity in text, right? And it is storing the code here. My site, polls, flows, profile, NLTK, runtime, right? All of that is stored here. And it has to be stored in the same exact manner also. There shouldn't be some like a folder inside which all of this is present, or you have gone inside the my site only and have excluded the polls and things like that, right? Because if you have actually stored your code or uploaded your code in one of your repositories in a manner which is different from this, then Heroku won't be actually able to understand if you have the full code with you or not, and it will again and again, provide you with an error that it was not able to deploy your project. Right. So once you have uploaded your code in the similar manner, go onto your Heroku account, right? Go onto your Heroku account. If you haven't had a Heroku account, just create one. It is very easy to do. It asks for your basic information like name, email ID, phone number, if you are affiliated with some organization or not, stuff like that. And once you have done that, once you have logged into your account, it would redirect you to your personal dashboard, right? So click on new here and then click on create new app. So it will ask you to just type in the name of the app, choose a region. There's only two regions here. Then click on create app. Once you do that, this app would be listed in your dashboard, right? So I have three apps for now. And since I've already created an app for the similar text, here the name like suggests that also. So click onto your app, right? Once you have clicked onto your app, go to the settings option, and inside that scroll down to the build packs. So the first thing that you have to do is click on add build pack, then go to the Python, select Python, and then click on save changes. Once done that, it would show something like this, that Heroku Python build pack is now accepted to be used as a build pack for this app inside your Heroku account. The next thing to do is go to deploy. Right, so once you go to your deploy option, you can see that there are three methods for deployment. One is Heroku Git, one is GitHub Connect, one is Container Registry. So you have to click on GitHub Connect. Then it would ask you to log in into your GitHub account using your credentials. So once you have done that, it would show something like this, that your GitHub is now connected. And the next thing that you have to do is to search the name of your repo, right? The repository in which you have stored your code. And once you search that, click on the search option, then it would show you the name of your repo and ask you if you want to connect that or not. A button will be shown here, right? For the connect option. Click on connect. Then once connected, it will show something like this. Connected to your ID, repo name by your ID, right? Once this is also done, scroll all the way down to manual deploys. Now choose the branch that you want to deploy. Since my main code is inside the master branch only, I'm going to choose master. Oh, there's only one branch only. Again, if you have different branches, choose the one that you want to deploy on, then click on deploy branch. Once you click on that, then officially Heroku starts to set up your code onto its server, right? And you can see that from here. So this is going to take some amount of time before it actually finishes the setup of your code. And the first thing that it does is, okay, wow, why is it taking so much of time? Right, so as you can see here, the first thing it did was take the Python version from runtime.txt, understood that Heroku is to use the Python build pack. Then it is installing all the requirements using the requirements.txt file, right? Once I have done that, it is also downloading the NLTK corpora, the package, right? Stopwords package from the NLTK corpora. And once it has done that also, lastly, it has run the command python manage.py collect static. Again, this is a command that is specific to Django, and it is used to store all the static files inside the static files directory we had set up inside the settings.py file. Lastly, it compresses the files, right, and then launches your server, meaning that your server is now ready to use and has upload and has the code up and running, right? So this is going to take some time, and once it has done all of its processes, right, the automated processes, it would tell you that deploy to Heroku is done, and you can click on view to go to your website and see the website is now loaded. You can just click on, yeah, just click on this and just click on the submit button, and it is now giving you the similarity value here, right? So with this, we have also completed the third part of the project, that was to deploy our web application on Heroku.